So these are some of the exercises from the textbook. And so the reason I'm making this is to help people understand why when do you square the number in the denominator that for the vertical asymptote. So we see a vertical asymptote at -3, so x plus 3. And then we see a vertical asymptote at x equals 2, so x minus 2. But you see how this function is acting like 1 over x squared? So that tells me I've got to square that term. And then, of course, you have to finish this problem, find the zeros and all that. Here I'm seeing 1 over x, and here I'm seeing 1 over x squared. So it's going to be for that one, we'll do x plus 2, and of course that's heading in opposite directions, so that's acting like 1 over x. This one's heading the same direction, so at x minus 4, or x equals 40 and not 3. That has to be squared, and then of course you're going to deal with the numerators and everything. For the next one, let's see. So here, neither one is heading off in the same direction. So both of these are going to have, let's see, x minus 6 or x plus 3 because the vertical asymptote is at -3, and then x minus 4, and that's there. And then we see 0. This one I'm going to finish because this is, it's right there. I see it crosses the x-axis, the origin. I see it crosses the x-axis at +3, and then I see a horizontal asymptote. So, and I see this is x squared on the bottom, x squared on the top. I just got to put the horizontal asymptote right there, and that's the equation of that graph. Last one, both of these are heading in opposite directions. So, and actually this problem is just like the last one. Why don't you stop the video and see if you can do this one? So here I'm going to go ahead and do it. So I know I have got a vertical asymptote at x plus 2, x equals -2, and then x minus 5, and both of those head in opposite directions. I see a 0 at the origin, I see a 0 at 2, and I see a horizontal asymptote of 2, so that's what you do. Okay, hopefully this helps.